A GATE 2016 question that involves work done is solved. Problem statement is given. You can read. The data given are pressure and volume at the start and end of the process. During the process, pressure varies linearly with volume. So pressure at the beginning, volume at the beginning, pressure at the end, volume at the end. In addition to this, data of gas constant is given. We need to find magnitude of work required for the process. Look for the solution. In the first line of the problem statement, it is given pressure varies linearly with volume. If you generalize this one, PV power n equal to constant. If n equal to 0, it is constant pressure process. If n equal to infinity, it is constant volume process. Both are linear. Constant pressure process, a horizontal line in PV diagram. Constant volume process, a vertical line in PV diagram. For a constant volume process, there is no work done, and hence it cannot be a constant volume process. Also, from the given data, we cannot say pressure is equal to 0. That means we cannot assume n equal to 0. Hence, we cannot integrate PDV to calculate the work done. Alternatively, we know in a PV diagram, the area under the curve is the work done. We will now plot the process in a PV diagram. Initial state 1 and the end state 2 are shown. The process that connects these two states are linear, is linear. Now, what is the work done? It is the area under this line 1 to 2. To calculate the work done, we can solve it graphically. For that, this area is redrawn separately here. The area can be divided into two. For easy calculation, the upper part 1 is a triangle and the lower part 2 is a rectangle. Therefore, the area of the curve is equal to sum of area of the triangle and the area of rectangle, which is written as of BH1 plus BH2. So of BH1 is the area of triangle, that is region 1. BH2 is the area of the rectangle, that is region 2. What is this BH1 and H2? To define these in the PV diagram, consider the data given. Volume corresponding to state 1 is 0.2 and state 2 is 0.1. The pressure corresponding to state 1 is 100 kPa, state 2 is 200 kPa. And what is this B H1 H2? B is the difference in volume between the end states. H1, H2 are self-explanatory. We can now substitute W1 to 2, that is the area under the curve, which represents the work done, is equal to half multiplied by, instead of B, substitute 0.2 minus 0.1, or the final state minus the initial state. Final state is 0.1, initial state is 0.2. H1 is equal to pressure at state 2 minus the pressure at state 1, that is 200 minus 100, plus, instead of B, final volume minus initial volume multiplied by H2 is 100, that is the pressure at state 1 minus 0. So here the pressure is 0. Calculation of this one yields W1 to 2 is equal to minus 15 kilojoules. Why this negative symbol? Look at the data. Initial volume is 0.2, final volume is 0.1. Volume decreases. Hence, it is a compression process. Compression needs work input. So work is done on the system. That's why negative symbol.